recap our experiment so far. Your teams of pharmaceutical biochemists that came up with a COVID pill and wanted to test whether it actually cures COVID. You're doing great. You had, let's see, you had a bunch of college kids who all had COVID-19. You managed a bunch of variables like their age, like how long they'd had COVID. You wanted to, if you had the budget, house them in a facility where you could control what they eat and maybe how much they sleep. That was great. We figured out that you can't just give them all the pill, right? Because of that well-known placebo effect. If you give them all the pill, you got nothing to compare it to, right? So you're dividing them in half. You're giving half the college kids the pill. And half of them, what? An empty pill, a placebo. So that if the placebo effect's happening, it's happening equally to both groups, which is great. And then we decided there was several things you could measure. Since COVID's weird, you were going to measure both the test results, like time between your first positive test and your first negative test. So you'd be measuring duration that you tested positive, but also maybe the duration and severity of the actual symptoms if you were symptomatic. Sound right? Did I forget anything? So that was good. There's still one big problem with this experiment, but let's first of all dissect what you've got. Let's look at, and this is what you've learned as the scientific method. Write this part down. It's not the scientific method. It's one of our more powerful ones. Experimental design is, it's important. It's one of our main tools. It's used to test a hypothesis. You know this part, right? What we'll talk about now is kind of what any good experiment you should be able to pick out of it. So any experiment, first of all, is going to have three different types of variables that you will need to be able to pick out. Do you remember this? You've been taught this before? It's not hard. You're just going to have to kind of get the distinction between what we call there's the variable that you change on purpose between two groups or sets of trials to see if it actually matters, to see if it makes a difference. What do we call the thing you change on purpose?
Independent.
Good. Independent is the most common name for it, the independent variable. Some of you have learned different terms for it. Some books call it the manipulated variable, the explanatory variable. Those are great. They're actually a little bit more descriptive than independent, but since independent is so much more widely used, that is what we are going to use. Simply put, it's what you change on purpose between the groups or trials in your experiment to see if it affects a particular other variable. That other variable, the thing you're actually, it's the data you're going to be taking, the thing you're going to be measuring to see if your experiment worked. What do we call that one? Allie, what's the, if independent is explanatory, what's the? Response variable. Okay, yeah, manipulated and responding is another way people have it, but we call it mostly what? The dependent variable. Good. That's the thing that changes because of what you did with the independent variable, or you hope it changes because of that. It's the thing you're measuring for. COVID experiment. What was the independent variable? And phrasing is important here. You're going to find that out. What's the independent variable? What's the thing we changed on purpose between the two groups to see if it even mattered?
What pill did you?
That's it. I like how you said it. Which pill they got. Because some of you are going to be tempted on a question, you're going to say something like, the independent variable is the pill. Well, that's really just a noun. You need to describe what was different between the two groups. They each got a different pill. That would be acceptable. Which kind of pill they got would be acceptable. Type of pill is fine, but don't just say pill. Okay? Good. And so then what was the dependent variable? We actually had 3 that we mentioned.
Like the living, like everything being the same, like environment.
That's what we call managed variables. The dependent variable is the thing we hope changes and that we're measuring for between the groups.
They like how healthy the person is, or like how effective they are from COVID.
And how do we measure that? So time between positive and negative COVID test was one dependent variable. What was another one? Time between negative and positive, or positive and negative COVID test was one. The duration and severity of the symptoms would be the other. Yeah. Good. Then we just have to name the groups that we put the college kids in, because we name them. You already know, I think, the group that gets the placebo is called the control group. The other one, oh, sorry, managed variables. I didn't say that. But you know those. Same diet, same age, had COVID the same amount of time. That is a set of variables you'd want to manage. Picking college kids takes care of some of those by itself. Then we got the groups. The experimental group. Or trial, because it's not always a group of people or a group of animals. Sometimes it's tests you're running. How many tests I did this way and how many tests I did this way. But the experimental group is the one where the independent variable is altered. Meaning the group that gets something different. The group that gets the thing that you're really testing. In this case, the group that got your COVID pill. The control group, of course, is the group where nothing's altered. What's wrong with you? I screwed up. You just had a face. Did you know that Erin's here?
Where?
I can't see her, but she's here. She's on the meet.
Oh,
And she's watching. You want to say anything to her?
no.
What do you want to say?
Hi.
Katie says hi.
Is it just her?
She's still on the show. This is the first day I'm trying live streaming, so. Yeah. Oh, there she is. Here. So independent, dependent, managed variables, experimental and control groups, got to be able to pick those out of any experiment you read about. And you're going to read about a bunch of them today. And you'll have to identify those things. But let's go back to your COVID experiment, because there's still one big problem, and it's related exactly to what we talked about yesterday. It's related to big, fat human brains. We took care of the patient's big, fat brains, right? They're not any longer, there's not a difference between the placebo effect in the two groups, but there are some big, fat brains we haven't accounted for. Whose? Yours. You're a huge problem. You know why? You invented the pill. Would it be good for you? Do you want the pill to work? Would that maybe make you an immense amount of money? Like buy your own island kind of money, maybe? Yeah. You really want this to work. You cannot trust your big fat brain during this experiment. You absolutely cannot. Like it's the difference between like, okay, let's say you're my two groups and I know you're the control group and I know you're the experimental group and I know you're the control group and I come over here and I say, hey, how are you feeling today? Got my clipboard.
Great.
You look fantastic. I
Thank
mean,
you.
like colors back, everything's, I'd say what, 95, 100%, something like that? Yeah, good. All right, full recovery.
How are you? Terrible.
Yeah, you don't look good. Like color's not good. Like, yeah, you're all congested, right?
Lying.
Yeah, like not breathing very well. It's not good. Sorry, dude. Not recovered at all. You see what I'm doing? I'm influencing things because I know who's in the experimental group and who's in the control group, whether I know it or not. Like that's very exaggerated. Obviously, I'm going to try not to do that. But my subconscious is going to, just like yours did, or just like the patient's did, my subconscious is going to want to believe that she's feeling better and he's not. How do I fix that? Can you think of a way? It's not as hard as it sounds.
I'm thinking you could have a team that does it for you.
So if you have the budget, yeah, you could hire somebody else. Oh, you should write that down too, sorry. If you have the budget, hiring somebody else to carry out the experiment for you could work. That somebody would have to be completely impartial though, which is hard. How could you do it even if you're still the one doing the experiment?
You could have like a script that you have to say for each person.
That might take care of like, if I'm going to give you a lot more precautions than you because I know you're the experimental and you just get a sugar pill, still doesn't handle the fact that I could be skewing my own data as I take it. How do I control that? Allie, what do you think?
Well, you have to be able to blind yourself when you're giving out the pills so you don't know who has what.
So what's a practical way to do that? How would you do that without losing track for your data? Easier than it sounds.
If you have someone like someone from your team, like give them the pills and then they don't tell like the other person records the data.
Whoever is giving out pills and taking data better not know who's in what group, just like the patients don't know. Whoever's doing the work here needs to also not know. Bunch of ways to do that. I mean, even if it's just you, if you got a large enough sample size, 100 pill bottles, randomize it. Keep track on a spreadsheet of what number pill bottle gets control and gets experimental. But you don't know while you're doing the experiment, and you don't look until after all the data is taken to see what they are. Does that make sense? Also, if you've got someone else that can be working while you're keeping track of what's what, they don't know, and they're the ones giving the pills and taking the data, that's great, okay? So the patient's not knowing what group they're in, that's called single blind. Researchers not knowing either, Allie was absolutely right, we call it blind, right? Double blind. And double-blind design is absolutely essential when humans are involved, both as subjects and experimenters. So, I think we're there. I think we're to the point where we've got a good experiment. Neither the patients nor you know who's in what group until you're done taking data. And now, once the data is taken, to sort of finish up with the scientific method, we analyze it, right? We take the numbers and we crunch them using statistical methods. We try to find out if the average recovery time and duration and severity of symptoms is significantly different between one group and the other group. If so, maybe we've got something. Maybe. Last thing we got to do is find all the variables that we weren't able to manage. What are all the things that might be creeping in to show a difference between our two groups that aren't our independent variable? Because you can't ever manage all the variables, right?
How strong or weak someone's immune system is.
Sure, there might be differences in their immunity. I mean, people are different genetically, genetic differences. I don't have the budget to try and genetically test everybody and make sure they have all the same markers. Can't do it. So analyzing those errors is an essential step. It's not that you're trying to say that you didn't have any. They're always there. What you want to do is call them out.
Excuse the interruption. Matthew Malone, would you come to the attendance office, please?
You want to call them out in your paper and say, hey, here are the variables we couldn't manage. Here's why we couldn't manage them. And here's why we think our results are valid regardless of these errors. What do you think? Good? Lynn? Good. I wasn't going to turn it on. So what's left is to practice identifying all these parts in different experiments. It's going to be easy on the first one because the first one involves a pill on this paper. The rest of them don't. The rest of them are totally different experiments involving totally different things. Some of them don't even involve humans. And you're going to still have to pick out the independent, dependent, managed variables, the experimental group, the control group, and maybe even say how you would make this experiment double blind. I'm going to give you the rest of the time in class to work on it. Please do get as much of it done as you can so that you can ask questions if you don't understand what's going on. And remember that phrasing is important with the independent variable. Don't just say the pill. Don't just say the shoes. What type of pill? Which shoes he was jumping in? Sorry? We are not working in groups. This is you. I want to know you can do this. Miss anybody? All right. I'll check in with you in a little bit. Stop recording.
Pardon the interruption. Abby Bazell to the front receptionist desk, please.